Okay, so I guess I'm audible. Uh, Today we start off with the sliding into technique. So I just saw array. So these are all the elements. So first, we need to understand what is sliding window technique. Right? So previously we had go through the two-pointer techniques where we just make sure two variables, left and right, and then iterate as we need to get the output. So here there are two types of sliding window. One is fixed length and another one is variable length. So in some questions they specifically asked like they had given some numbers like k is equal to 3 or k is equal to kind of thing. So that represents the size of the window. If it's so, I think we can just see the fixed length later. So first we try to focus on the variable length. So variable length sliding window, it's like little bit like a two pointer, but let's say in two pointer, let's say here one pointer is there, and then if here is one pointer, we just if we need to add the index 0 and then index 3. If we need to add these two indexes, so we just iterate the next one or some kind of pointer, and then we just add up and then give the answer. Right? So, what if we need to we need the total sum of the all the number in between these, including these two. So in this case, we are just using sliding window where it adds up these two 5 and the 3 8. So this is basically difference. So if this will be two pointer, if adds all this, then it will be sliding window. So like we can move the window like this. We can just do like that, and then do here like this one, or just expand again and then again and again and again. So based on the question we have and the answer we need to solve the problem, we alter the window size. So this is basically a sliding window in simple layman terms. So now here they are given some problem. So here what they are given is just so we need to write a function, right? So in that, let's say, so each integer represents some fruit. Let's say 0 represents an apple and 1 represents a banana. The 2 represents some guava, mango, something. And then same like 3. So in this, we need to uh, get the maximum number of fruits. That is the main goal. And there is some twist in there. So they had given some condition. The condition is, let's say, so let's say if I can get these two right, and then get these three, and then get these four. But the condition is you can get the maximum number of fruits without the third distinct type of fruit. Means you can let's say if here let's say three means apple. Let's say three means guava. So here Goa is there, and then here also Goa is there. So I can take it. So it's both are same kind of fruit, so there is no problem. And then here is another type of fruit. So it's a second type of fruit, right? So I can take this one. Here it's a third type of fruit. So I cannot able to take this. So the subarray I have is this one, and then this one. So this are the two distinct fruits, and then the condition is I cannot that if there is a subarray, that should not all three fruits contained in that one subarray. So that's the simple terms. So I can able to fit two types of fruits in one subarray. Okay, so now the subarray we have is here are the subarrays, right? So I can 3 comma 3 comma 2 is one subarray, right? And then I can take 3 2 here I cannot take, so 3 comma 2 is one subarray, right? And then 2 1 2 1, yeah, so 2 comma 1 comma 2 comma 1. So these are both two fruits only in those subarray. So and then 1 comma 2 comma 1, yeah, this will be one subarray. And then uh, 2 comma 1 will be on subarray, and then 1 comma 0 will be on subarray. Okay, so these are all the possibilities we have. So now, so what we need to do is, so let's try to solve this in a I think we can just able to solve this in a for loop approach if we use a nested loops. So let's say I had a I in there, then j is in here. Okay, so basic two-pointer technique, like that kind of thing. So I just make sure the condition. What is the condition we need to do? So that's the main thing here. So let's say we had okay, so there are some peoples in joined in the stream. So if you guys have any like idea on how to solve this, you guys just can post it on the comments, or else yeah, we just try to solve this one. So here what we can do is we just iterate the j. So we just see whether we just create an empty array. Let's say we just create an array. I just append the ith element inside the array. So this will be like, and then after appending I just check whether. So the condition here is we need to check whether the J is the distinct fruit or not. So that's the thing we had, right? So how can we do that? So can we do like this? Let's say, so in this, we can use set data structure. I think you guys are familiar with this set. So, so in set structure, unlike array, we cannot able to store the duplicate values. Let's say, so if three is there, and then again three is there, right? So it doesn't count three. So just we move j to the next one. So here the new element is came, right? So we just add the two in here, and then just move the j pointer here. Just a second. Okay, sorry guys. So I think now there is a new element, right? So here we have some condition. Let's say if the length of set is greater than two mains, we just make the set append like sorry array dot append set. So I think we can do like this. So that we can able to find out. So here after this condition we just iterate one I, right? So I is equal to I plus or equal to 1. So this will be a piece of our code. So yeah, so I think we can try to code in some compiler. So I just create a function quickly. So that some fruits. Yeah. So I just insert and keep an array. So here what we need is, so we need a maximum length to be set to be 0. Okay. So just to make sure that the length doesn't exceed 2. So next I just use a for loop. So in this what we need is, so let's say I need a length of an array, right? So here for I in length of length. So and then so here we need to set the j uh, next to I, right? So from here we need to iterate j. So from 1 to n it need to be uh, iterate, and then sorry let's say if we move I, then it will be a problem. So I think it will be I plus 1. Okay. So here the condition will be let's say if the length of set of an array, so I is to j, so this is less than or equal to 2 means, so we just update the max length. So yeah, so this will be the code. So but we cannot able to do this, right? So it's a nested for loop, but we need to consider the optimized solution only. Okay, so from here, I think I messed up the last problem. We just stop right there. So I think we need to concentrate more on the basic thing. So let's say we have sliding window technique here. So solve problem that involves subarray or substring or window. So first, the main thing is solve problems subarray or substring or window. So for these kind of situations, we just use the sliding window technique, right? So okay, so we just try to no, instead of repeatedly iterating over the same elements, the sliding window maintains a range that moves step by step. Okay, we already see that. The main idea is to use the result of previous window to do computations. So I think, so let's say it will work like this. So in two pointer approach, So let's say we have like this one, right? So in two pointer, we just use two pointers. If we need to add, let's say we just use the target sum. So, so, so guys, please wait for some minutes. So I guess I just have a short break. I had some important meeting. Sorry. Okay, sorry guys, so we just start off. Okay, so yeah, so this is where we live. So here, so as I said, so in two-pointer techniques, let's say if we need to, here we had some targets equal to some kind of, let's say, 7. Let's say 7 is the target. We alter these two pointers based on that, right? So here we just add these two values of the left and right pointer, and then if it's greater than the target means we just lower the sorry, we just decrement the R value. Why? Because it's a sorted array. So that's the other case, right? So the basic scenarios, we just take those two pointer values only. So in this sliding window, what we need to do is, let's say, if the answer of the target we need is, let's say, 3, 4, 5, 6, 11. Okay. So 11 is the target. But unlike the two pointer, so we do not just take the two values only. We just need the 11 from all uh, the whole subarrays. So it's kind of a subarray. You guys know what is a subarray, like, right? So for example, this is a subarray. This will be one subarray, or else like let's say one, two, sorry, one, and then two, and then three. So this will be a subarray of this main array. Okay, so or else we can just say this as a subarray. So this one, two may be a subarray, one, two, three maybe is also a subarray, one, two, three, four is also a subarray, two, three, four is a subarray, three, four is a subarray. So it's all subarrays for this main array. So let's say we need a target 11 from this main array. So we can just introduce a new variable like we just uh, let's say result. Okay, not result. Maybe okay. So yeah, we just say as a result. So we just use the result as 0, right? So here we just place the R and then increment, so add the value L and R to here. So this will be 3, right? So now we just move the window here. Moving the R pointer is not like the two pointer. So moving the R is not like, uh, so we are just moving the value. So we are sliding the window size. So this is the window size. So we are sliding the window size. Now the value is 3. So add it to so add in the result. So already 3 is there, plus 3, 6 is there. And then again slide the window to the next index. And then here the value will be 6 plus 4 will be 10. And then again slide the window. So here, let's say here the value is 15. So target 11 is not there. So we can just return false. So this is the basic idea on how the sliding window is working. So yeah, we just try to solve some problems. So here they had given some maximum sum of subarray with k elements. So here they had mentioned uh, the window size. So window size is 3. So I explain you in a bit. So we just try to so 5 to minus 1, 0, 3, 5 to minus 1. and 0 and then 3. Okay. So here they had mentioned that the k value is 3. Here the k is the window size. So yeah. So we just understand the first we try to understand the problem. So the maximum sum of a subarray with k elements. So given so they are given an array and an integer k. You need to calculate the maximum sum of an subarray. So which means uh, okay. So here the size is k, right? So first we try start from the zero the text 0, 1, 2. So the since the window size is 2, 3, right? So we can only take three elements. So just add this subarray 5 plus 2 7, 7 minus 1 is 6. So first we have for this we have 6, right? And then we move on to the next index. For this 2 minus 1 is 1 and then plus so it's 1. So then move on to this. So minus 1 sorry plus 2 is there, and then there is no element, right? So for this, so there is no index, so we are stopping right there. So here the greatest element is 6, so 6 will be the answer. So this is what they are asking for. So yeah, so first we try to understand. We first try to solve the problem. Okay, so how can we solve this? So we just make sure. Let's say so we need this element need to be added, right? So first I keep L here. So just for reference, it's some pointer, some variable. So and then R is also here. Okay. So both L and R is here. So we need to move R three steps. It's already there. So move here. So sorry, before moving, we just need to add, right? So first I just wrote it here, wrote down here. So let's say result is equal to 0. Okay. So now result, sorry, result plus or equal to array of R. Okay. Now after adding to the result, we just increment the R. So, but here we had condition, right? So the window size is 3. So we need to loop R only three times. Okay, so here it will two times only. So let's say, how can we do that? Uh, for R in range of, so the R pointer should be start from the L, right? So the where the L is, so from there the R need to be started. 2 L plus 2 can we do like this? So L plus 2 means so let's say if the L pointer is 0, 0 plus 2 means 2, so R can be moved till the second index, right? So this is the condition. I hope it's right. And then till then what we need to do, first we need to add the R. This step will be there. So we don't need this one since for loop iterates itself. Okay, so here, yeah. So we just add the result to there, right? Here and then here. Okay. Now we had a result of 6, right? So 6 is there. Now what we need to do? We need to move the L pointer by 1, right? So first we need to increment the L. So how can we do that? Okay, so for this. We need some loops. So I guess we can use while loop. Uh, while r is equal to true. I can do like this. Why I just use this means. So from the dry run, we can understand that here the array is not always even. So it's an odd array, right? So here, if the window size is odd, right? Here the three is an odd number. So from here we cannot able to find the r. So what we need is, so if r, we just move here. If there is no, we just come out of the loop, right? So while R is true, uh, we just what we need to do. Okay, so Mhm. Yeah, I think I'm doing something wrong in here. So this is the solid condition. We don't need to change this one, I guess. So the for loop one. 1, 2, 3, right? So and then after that we just move the L. So I just wait a minute. I just use while loop. So while something is true, when we need to move the L element. Okay. So the after the for loop statement, right? So we just need to iterate the L plus or is equal to 1, right? Uh, if we do this one, we just introduce R is equal to L. So that if we add R like the another index, we can make sure the R is uh, same as the Lth index. So here we need to make sure R is equal to L. Okay. So after this, what we need to do is, yeah, this loop will be goes on. So we just keep this loop. After the loop, we just increment the L, right? So yeah, I guess this will work. But what is the condition? When do we need to stop this loop actually? Okay, so I think next the R is iterate 3 times, right? So one, two, and then three, and then L is increment. Here I guess we miss out something. Means what? Like if the six is there, if one is here, so let's assume that. So the number is greater from this, so we didn't even iterate, right? So we just store, let's say, so one will be stored here, and then again the loop will goes on. The loop will move. So we need the maximum element, not just the last. So here this will return the two will be the result. Okay, so I think you guys can understand. So for that we need result is equal to max of result, comma. No, I guess this will also result plus or equal to something. So after an array is over, okay, so I need two variables. So in this scenario, I tell you why. So here, local is equal to 0. I just make sure, and then here also I put a local is equal to 0. Okay, so we just need to calculate two maximum. So here the value, the whole subarray value will be stored in the local variable, and then the result, main result. So since we need a maximum element, so I just put here result is equal to maximum of result comma local. So let's say if result is here, the result is 2. So let's say here the local value will be 6 after adding all the subarray elements. We need to compare whether the final result has the greatest number. So for that we just max it out. So yeah, after that we just increment the L pointer. I guess this will be right. So yeah, I think R will be here. So why the R means? So after here, so wait guys. So I just tried on this code from beginning, so that we can easily able to understand. So okay. So this piece will be the code. So I, if we have any issues, we just try to update it. So yeah. So initially, sorry, we just L is equal to 0. L comma R equal to 0 comma 0. Okay. Yeah. So the L will initially the L will be at 0 pointer. The L and R will be at 0th index, right? So now while R is true, right? So it will goes on inside this loop. Local is 0. So R is equal to L. So there is no need. Okay, so I guess it will okay, yeah, we just move on. So for R in range, so from L comma L plus 2, right? So L comma, so first it will take the 5 and then add it to the local and just increment till here, right? So 4, 5, 6, 7, and then minus 1. The local value will be minus 6. Answer is 6. And then we just try to find the maximum. So 0, comma 6, the maximum will be 6. So store it in the result. And then just move on. Yeah. So again, well, R is true. Yeah, the R is true means. So what we need to do is, uh, again, we said local is equal to 0. R is equal to L for in range of L comma L plus 2. So they will move here and then update result and then again move here. So again move here. 1, 2. Here there will be no R, right? So I think there is some problem in this code. We just check it out. So I just try to code it. So guys, if you have any idea on this, you can just post it here. So maxi, let's say I had an array, right? So I just make result is equal to 0 and then L comma R is equal to is equal to 0. Okay, just create an object. The output is zero. I don't know. Uh, I think this the problem is it doesn't even go inside the loop. That's the problem, I guess. So let's try variable. So the problem is here. Okay, so to solve this problem, so I just try to mention why the problems occur. So here, as we said, the R is out of range. So that's the problem. So when the L is here, like this index, we check this one and the R is. So for this, we need to make sure that L should stop before the K indexes, right? So let's say what I mean is, so L, okay, like I just try to write an for L in range of, so here the window size is 3, right? But what is the total length? 1, 2, 3, 4, 5, 5. Okay, I guess uh, length of array plus 1 minus k. I guess this will work. Why this means, let's say the array size is, sorry, 1, 2, 3, 4, 5, right? So the 5 plus 1 is 6. 6 minus 3 is 3. So this will stop from 0, 1, 2. Oh, sorry. Not 1. So I just try to remove this one. Okay. So now, yeah. So I think this will work for in range of length of array minus k. Means 5 minus 3 is 2. So the L will be stopped at this one. Okay. But I think if we do this one, the complexity must increase. Let's say I'll explain this for L in range of length of array minus k means I just didn't mention here. K, right? K is equal to 3. Then I just pass it in the parameter. Okay. So yeah, maximum. Okay. For L in range of KL minus K. Okay. So local is equal to 0. I just initialize a variable. For R and range of L comma L plus 2 means L, okay. We just store the R. After storing this, we just max it out and then we don't need this one. Yeah, I guess it will work now, but the value is 7. So there is some problem. 5, 6, 7. So L is here. Then R is also here. I think it doesn't count this minus one. That's the problem here. From L plus L comma L, I think we can use like this one. L plus K. Yeah, this will works. Yeah. So yeah, this is the answer. I guess it just so even if it works, so the time complexity for this code is O of n, right? So we need to optimize this. So we are using nested for loops here. If you guys have any idea on optimizing this, you guys can um, put it in the chat. So someone asked what's the question. So the question is find the maximum sum of the subarray with k elements. So this is the problem. Wait, where is it? So yeah, this is the problem. So so this will be the given array, and then the answer is 6. So I already coded a naive solution, but it's the rank complexity is still greater one. So often, if you guys can try it out and comment the optimized solutions. If you guys can. So I think uh, some guys are watch our stream. So guys, if you guys can able to solve this problem, you just try to solve in sliding window technique. So and optimize the solution. So if you guys can just post it here. So no one. Okay, so yeah. So there is no one. So we just move on to the optimized solution. Okay, so we just move on. So before seeing this one, so I just need to learn the cadence algorithm. So there is an algo which will be very helpful for these kind of problems, especially for sliding window. So if you guys see any subarray, substring, or window kind of thing in a problem statement, so you guys can try this technique out. So you just guys try this out. And also we just try to learn what's the cadence algorithm before seeing the optimal solution for this. So here they are saying. So sorry guys, I just made a mistake. Like before I said the about the time complexity for the code we had just coded. So it's O of n square, not O of n. So since there is a two for loop, I just saw now only. So hence there is a two for loop. It's O of n square. It's very uh, worst time complexity. So we need to optimize this. So yeah. So we just try to move on to the cadence algorithm. So so they are saying that the main idea is to traverse left to right. Okay, that's a classic one. Find the maximum sum along. The result will be the maximum of all the theorem. So there are two choices. They are saying. Yes, right. Okay. Extend the maximum subarray ending at the previous element by adding the current element to it. So if the maximum sum ending at the previous index is positive, then it's always better to extend. Okay, like this means the maximum ending at index I is equal to max of max ending at index I minus 1 plus I of I, the maximum value of something. So here they are shown some. Uh, so here they had some array. So they have two variables, maximum ending and then rest will be result, I guess so. So we just update both with the okay. Then okay. After we just add three to both of them. Then so minus eight is there. So now what they are doing is so here they just add the values in the maximum ending, but in the result section they only add the maximum value only. So they are store result and then maximum of result comma. the maximum finding ending, right? So here, let's say this one we already saw here, right? So here, in this, take this as a maximum ending, right? So this variable, and then result will be as it is. Here the values. So we just iterating and store the maximum. So here we are just iterating the value here, and this and here in result section we just store the maximum element. Okay, so that's they are saying. So here 7 is the greatest one. So here 7 and then since the maximum subarray ending at previous index is negative, it's better to start a new subarray. Okay. So here they add okay. So if we check here, the both values 7. So let's say here I just said we just add it to the maximum ending, right? So if you guys have a window size of 3, it will end here and the new subarray will be started. So if you guys don't have any fixed length, so if the subarray have variable length means how we need how we know that we just start a new subarray from here itself to get the expected output. So they are saying like so since the maximum ending goes on at the minus 3, right? So the extend the maximum subarray at the previous subarray, that is minus 3 into it. So here, since the maximum subarray sum ending at the previous index is negative, so the maximum ending is negative. So we can better start off the new subarray so that we can get the better output. So they are saying like that. So the algorithm saying like that. So let's start with the new subarray and then add these two and the next minus one and then adding this to the next two. Yeah, add that, add it. So 3. So 11 will be the answer. So yeah, by this we can get the 11. So yeah. So with this, so this is one example. So with this, we try to solve the our problem. So we already have some problem here, right? So we need to optimize this. So see any of them had yes. So someone had message. So hey bro, I completed much things in Python. I am in my first year sem of a bad season. Things left are whoops iterators and working for external data, JSON request. When to start is. So my suggestion, you can just give a glimpse or just see what's the how to create an object. So guys, I guess I'm audible now. Yeah, okay. So someone asked. So my suggestion is, uh, go and learn some OOPS concept, like how to create a object, how to create a class. After completing these two, better jump into DSA. That's my request. You don't need to work on the JSON request kind of things. So it's like if you are more concentrate on your projects, better go for that. So Other than that, you just go on DSA right away. So because DSA will be play a vital role in your placements. So my suggestion, just learn how to create a object and learn how to create a class and how to manipulate kind of things. Yeah, that will be enough to jump into DSA. So okay, guys, I think I am enough from here. So I'll start. So till now we had seen some problems, but I think we see only one problem, right? So but that too, it's not a optimal solution. It's a naive solution only. So I think we continue live from tomorrow. I just need to make sure this sufficient resources to make you guys understand. So yeah, from that I try to start from tomorrow. Thank you guys for joining my live. So if you guys are still there, thank you for your support. Please like and subscribe to the channel. Yeah. So okay. Thank you so much. So I think I had saw some Divyansh Yadav. So I have started groups, but finding it hard. So um, I guess whoops will be little bit hard if you dig deep into it. So if your main focus is on DSA, better just learn some basic hoops concept. That's enough for DSA. So you don't need to code everything like from inheritance, how to inheritance. So it will be useful only, but first learn concepts, and then in coding part just learn how to create object and class and how to manipulate those. That will be fine to start off with the DSA. And then it will be hard if you focus on the inheritance polymorphism, on how to code the whole inheritance. So you need to you create multiple classes and inherit the child to the parent. So it will be much difficult. So better you just learn the concept first. After familiarize with your concept, you can just try to code it on your own. Yeah, that's my suggestion. Okay, guys. So it's already time. So thank you so much for your support. Thank you. Thank you.